The objective today is to estimate the importance of servers to a network. So here's the table of contents. The first thing we're going to do is go over the 4 types of networks, and I really think there's just 3, but there's going to be this 4th one. This will be a term you can use to just better describe 2 LAN networks connecting to each other. The second thing we'll go over is the concept of packets and frames. To many of you, this will be review, and then we'll go over IP and MAC addresses, another thing that is a bit of a review, but we'll finish the lesson really strong with focusing on servers and servers' relationship to the client inside of a network. So today's lesson's all about data traveling. Do you get my little reference here with my Bitmoji guy? So let's talk about data moving throughout the air that you're sitting in right now. This concept is known as Wi-Fi, and this is our launching off point to better understand how LANs work. Because for the young people listening to this video right now, you're probably most familiar with Wi-Fi, and if you're on Wi-Fi, you must be on some sort of LAN. This is the smallest kind of network, and it exists anytime you have 2 or more devices connected to a piece of routing equipment. So we're talking routers or modems. And here in the school we have a router and modem for you to connect to, but at your own house it's provided to you by an ISP, this internet service provider. In Colorado Springs we have like Comcast and CenturyLink. So they provide you with this modem, and all the devices in your home likely connect directly to the modem. Maybe one device connects to another device and then connects to a modem, but chances are they're just directly connecting to this modem, and then they go out onto the bigger network, the internet, and that's your typical LAN. And I thought I should point this out. Recently, I took a phone, and using my other phone, I was able to download all the contacts that I had on my older phone. So I'm doing this through a concept called Wi-Fi Direct. And though both phones are in my hand and I'm looking at them both at the same time, it's not like they're directly talking to each other. They're going through my router or through my modem, which is a hybrid of a modem and a router at the same time. So it goes through there and then to the other phone. Now sometimes you're not using a LAN. I assume most of you have a ton of devices at home, but those devices aren't always communicating directly or communicating through that modem at your house. Like, for example, if I send my wife an email, that email goes all the way out of the house, all the way through the internet to some server somewhere, to Google's server, and then it gets put into my wife's inbox. And for her to access it, it comes all the way back to the house, and then she can open the email and read it, even if we're sitting like right next to each other. So it's not like we're utilizing the LAN in that case. And how do I know that's true? Well, you can use some network monitoring tools like Wireshark to see what happens when you do something, like send an email. And this is where an interesting thing occurs that's called network address translation. So there's a difference between internal and an external IP address. To help save space on the internet, or at least to help save the amount of addresses that can exist on the internet, someone decided to have this concept of an internal IP address. So inside my IP network, I have all kinds of IP addresses. Usually they start with 192 or 10 or something like that. So when we decide to use our devices at home to go on the net, all the devices' requests appear to be coming from the same IP address. So once the data is received, something called NAT takes place, and your router figures out which device in your LAN is the one that's going to receive that data. So you can have like multiple phones going out onto the internet, and they all have their own IP addresses, multiple devices as well, but all these requests are going through your modem and sent out under just one single IP address. And when it gets back, that's where the NAT figures out who gets what. So an internal IPv4 address will either start with a 10, 172, or 192. Your router's IP address is assigned by your ISP. So whatever this number is, Comcast, CenturyLink, they're the ones who decide what that is. And now the last number in an IP address typically is the host number. So that's the number of the device that's requesting the data. And this is similar to a MAC address you're going to find out soon. The host number needs to be unique, especially compared to all the rest of the numbers. But with the help of the MAC address, the router knows exactly which computer or device it's sending that data to. And I should also point out that a host can be just a node, so anything that has an IP address can be considered a host, even if it's just like a router and it's passing on its data to somewhere else. So this is a good think, right, share, I think. What is the host ID in these 4 IPs? All I'm asking you to do is write down the last number here, just to prove to me you're understanding this concept of a host. And if you're ever in need of a random IP number, you can get it from a random IP generator website. The way IP numbers are distributed is very technical, and you can read a few RFCs to better understand that. But for now, I just want to focus on this idea of evaluating the importance of servers to a network. Okay, so let's talk about this word, an internetwork. This is a network of networks, so this could be 2 or more LANs together. You can see the word internet inside that word, right? So essentially, this is the concept behind the internet. Multiple networks connected to multiple computers so they can speak to each other. Just think about that. For the internet to exist, we need certain sets of computers to just always be on. Sometimes they aren't, but the biggest websites have multiple data centers that can keep these computers on, and of course they have backups upon backups. At the time of this video, we have Hurricane Florence hitting North Carolina. If there's any servers there, and I know CompTIA has servers there because I tried to register for another exam and they say there might be difficulty because of the hurricane. The fact that a natural disaster can take out certain servers, it is going to be okay because the biggest companies, they have their backups, they have other computers that can take the place of those computers. And then if we get into why would they spend so much money on having so many computers where these big businesses are making money off of you going to their websites. So they really want to make sure you can access those websites at any given time. So think, right, share, what is an internetwork? And now I want to talk about 2 other reasons you might have an internetwork. If the number of computers in a single LAN has exceeded the efficiency of that LAN, or another reason to have this internetwork is the distance has exceeded the capabilities of that LAN. So we could talk about physical difference there. So we got LANs, internetworks. Now let's talk about WANs and MANs. A WAN is a wide area network, and this one's really simple. So all you need is a third-party ISP provider to be involved in routing the traffic. So just think of those big companies, Time Warner, Comcast, CenturyLink. If they're the ones doing the routing, then you have a WAN right there. And I've heard people say the internet itself is the largest WAN. So here we are with a WAN. Now let's talk about a MAN. This is a Metropolitan Area Network, and this word is just to describe a specific geographic region, and it could be a county or a city that is connected through a network. Now, if you've ever heard someone say intranet, this is a little tricky. They are talking about a private internetwork, so maybe a government or a large corporation would have this intranet. And if someone is allowed in that intranet, even if it's in a limited way, then that's the extranet. So if you have somebody outside of this intranet accessing or being given access, now it turns into an extranet. Think of it like the intranet is just being extra by allowing an extra person on their network. When I hear these words, I just think of the big corporate overlords on their private networks, conspiring against the common man there. So here's a nice diagram to kind of visualize that. So think of all these networks in the context of our last lesson. Last time we learned that computers are sending these bursts of data at about 1,500 bytes at a time. These 1,500 bytes are often called packets or frames. Now typically the correct term is frame, but a lot of people just say packets. And if you think about it, we're just a few bytes off, so it shouldn't be too big of a deal. And though these computers are going through these bursts, they're also pausing, well, thus the burst word, right? So they're pausing, that way other computers have an opportunity to send and receive data. And here's a good visual to think of that. So you start out with the data of just an application, and when 2 computers need to talk to each other, now we're talking networking, right? So there's the data that makes your Snapchat work on your phone. Now to send that video that you just made, you're going to have something called a header, and we're talking either UDP or TCP. So the data grows in that sense, and then you're going to have an IP header, so that's the IP address, the to and the from. And as it moves down, you're also going to add the MAC address, a part of that as well. And don't forget the CRC, that it's a check to make sure everything's correct. This is how your data grows from small chunks to a very large, well, 1500 up to 1526 bytes. And the cool thing about these bytes, or these frames, if there's a problem, then all you have to do is resend that one frame, not start from the beginning and resend the entire movie. Think about sitting at home and watching Netflix. That data is coming to you in chunks, and sometimes you'll experience this buffering where you have to wait a second, but eventually you get past the buffering, and sometimes you'll not have any more hiccups. That's because everything's just working perfectly. So I think at this point I'm getting a little too into semantics. I've heard networking guys talk about packets and they actually mean frames and vice versa. So just a rule of thumb here, advice to you young people. When you talk to somebody, try to listen to what they mean, not necessarily what they say. Another rule of thumb, just don't be a jerk, don't be a know-it-all, and try to correct people when they're speaking. Listen to what they mean. And at the end of the day, I've heard this analogy used that I think is a pretty good one. Think of a packet like an envelope that has a zip code on it, but not necessarily the street address. So that's the difference between a packet and frame. Once you get that MAC address, you have the specific computer you're going to. I went a very long time without ever knowing what this is. There's an aha moment when I realized my Voodoo account wasn't allowing more than a certain number of devices on it. I was wondering how Voodoo was able to tell what computer I'm using when I'm streaming the movies I have saved on there. Well, I'm sure they're using the MAC address to figure that out. Another way to look at this is the idea that a packet is framed by the MAC address. And when something is framed by something else, this is often called encapsulation. And it's similar to programming, the concept of encapsulation in programming. But when we're talking networking, typically we just mean this additional data, such as a MAC address. So here we are, finally at the server. So this is just a computer that can provide a service to another computer. Now some semantic sticklers here will want to argue over what constitutes a server. I like the definition of just the idea of a service. Some of your most popular servers out there are serving up websites or game data. You have these time and date servers. You have authentication servers. But when the client, that is your own personal device, when it's asking for a service, so we call the computer asking for the service a client. Of course, you can see how these terms can easily be used in the variety of networks that might exist. Even on a LAN, if one computer is serving another computer something, you might be tempted to call that other client a server. But for me, the big distinguishing factor is like this specialized software or hardware that servers have. You have specialized motherboards. You have a specialized operating system, often Linux. Linux is by far the most popular operating system for servers today. And you don't necessarily have to have all this fancy equipment and operating system to have a server in your network. There's basically two models you can have, either a peer-to-peer network, so this is where most computers function as clients, or servers in any given moment. So maybe think back to my intranet example. That might be where you have clients, where you might have computers acting as clients and servers just randomly depending on how their network is configured. But probably more common is a server-based network where certain computers take on this specialized role and their only function is to serve. And when you have these types of networks, a server-based network, you'll often have what's called a system administrator. And this is a really cool job. I'll go out and find some more details to give you about such a job. You might want to grow up to be a system administrator. So a system administrator's job responsibilities vary greatly among employers. In a large enterprise, and this word just means business. So in a large business, sysadmins may be used to describe any administrator who is responsible for specialized IT systems, such as the one that supports servers. Smaller IT departments, I know of a few, they generally give this title to a position where they have a wider scope of responsibilities. So not just managing servers, but they may provide support from end user desktops, computers, so they might be supporting clients, that is the users of the network. They might be supporting the LAN or the WLAN. or the VoIP, the voice over IP system they got going on. The guy I know, he works for a company and he's doing mostly cloud storage stuff. So he tells me funny stories where like a person said they don't need servers, they have the cloud. And he's like, what do you think the cloud is? The cloud is servers, like database servers. There's different types of servers, right? Remember over here when I said we have servers for the time and date to authenticate, so passwords, making sure those were correct when compared to specific usernames. You have servers for websites and games. All kinds of servers out there. Now, if you use Google Docs, you understand that this is a cloud because your doc is not stored on your local device. It can be both, but that document is just on another person's computer far away, that other person being Google, the company. Right? Their alphabet, I guess. Strange name for a company. But anyways, depending upon the organization's culture, the system administrator may also be referred to as a sysops guy, a system operator, or just a support engineer, like application support engineer. So let's end this lesson by answering the essential question. Why is it helpful to have machines act just as servers rather than relying on clients to serve each other? And I'm going to give you this picture as a large hint here, but I really want you to make a good inference here to answer the question. So we're at the end of the lesson. Pick an IB attribute to compare to today's lesson. We're learning all about networks and servers, right? And then a very simple DOL today. Just order these based on the greatest need for a server to exist to the least.